This is a C++ program written using SDL, which plots the uh, Mandelbrot set onto the SDL window. And these are the header files, these are the libraries which I've included. The first one is the SDL.h, which will be used in order to render the window and the pixels. And after that, I've included the IOStream library, which will be used for simple cout statements. And then we also have a vector library. The need for a vector library in this code was to uh, help generate the data variable in which we will be storing the grid values or the pixel values for the window. After that, we have include complex, which will be used to work with the complex numbers, because we're dealing with uh, Mandelbrot sets, so we will be dealing with complex numbers. So this is for that, and we also have a CMath library which will be used to uh, for the power function and some other stuff which I don't remember it that well right now. I don't remember it very well where I've used it, but I will see. These are some constants. The first two constants are about the dimensions of the window, which we will be rendering. And after that, we have a variable named int size. This size is equal to 1 initially. We can change the uh, value from 1 in order to, if in case we want an image of slightly higher resolution. Then we have rows and columns, which are just basically equal to the window's height divided by the size. So we're dividing the height of the window into a number of rows based on the size which we just injected into this variable. We also have another integer constant variable named as the upper bound, and it will be equal to 100 initially. Uh, this variable is this upper bound variable is setting the upper bound limit for the iteration count on the uh, on every point which we will be dealing with in the plane. And these are some functions which we will discuss later. This is the int main function, which is basically the main Windows function. And we have initialized the SDL library here using this. And then we have initialized two variables. The first one is the window variable, which is a SDL window pointer type variable, which will create a window named fractal and position it at the center of the screen, center of the monitor, and then we have injected the width and height of the window, which are basically the constants which we declared previously. And then we have another variable which goes by the name of renderer. It is also a pointer type variable which has the type SDL renderer, and it creates a renderer onto the in the SDL window which renders stuff onto the screen. And these are the stuff. This argument named as the SDL renderer accelerated, it basically uh, is allowing the renderer to use the GPU for multiprocessing, so that the rendering is a bit faster and smoother and doesn't take that long. Then we have created a vector, a two-dimensional vector. It's a vector inside a vector, and the innermost vector is of the type int. And then we have a constructor here which goes by the name of grid, and then we have initialized it. It has uh, the the outermost dimension of this grid vector is equal to the number of the outermost dimension is equal to the number of rows. And then we have in each of those rows we have initialized a vector which has elements equal to the number of columns, and it has the data type of integer. After this, after this below we have the usual SDL stuff. We declared a Boolean variable which has been initialized as true in the beginning, and we also created an event named as SDL event. It is of the type of SDL event, and this is this speaks of itself. This is the crucial thing here. We called the update grid function, and when we call the when we call the update grid function, then it updates the whole grid and validates them if the point lies inside of the Mandelbrot uh, set or not. Then we have two for loops nested with inside the next one nested inside of the other one, which will be used to iterate through every single pixel, or you can call them it as the every single cell on the grid. And after doing that, we have stored the value present inside of that grid inside an integer variable, and then this and this, and we have used RGBA to render it onto the screen.